Through this course, I have understood how physics plays a role in my daily life. Physics is used daily through the computer and cell phone that I use on a daily basis to TV and even the job I have. I will start on a journey through my daily life that leads you to understand all the relative physics concepts that I use on a daily basis. I first start out my journey with my cell phone. I light it up, it plays music, it activates, and an alarm goes off. After that, I head out to work. And at that point, I sometimes end up using a helicopter. And through this next slide here, I will show you how a helicopter works. I will show you a little bit of a YouTube video here that kind of explains some of the theories that will be explained later on in these slideshows and that were used throughout this physics class. And here it goes.
Pilots need incredible skill to get their very best out of these machines, but even a complete novice like me can take the controls. However, a little knowledge of the science of flight is a lot of help. Anyone who dares to take the controls will soon discover. I don't really know how it's going to be, to be honest with you. I think it'll be exciting, but I think it'll be really scary. Scary but exhilarating. When you're floating around in a ton of metal, it's reassuring to know a bit of the science that keeps you up there. The theory of flight covers some really important stuff, like how do you get up in the air? What keeps you there? And what happens if the engine breaks down? Useful stuff for passengers to know, but essential for pilots, as two complete beginners are about to find out. Marie and Tracy both work in the Royal Berkshire Ambulance Control Room in Wokingham. Ambulance emergency. When an emergency call comes in, it's up to them to decide which ambulance to send, and that doesn't always mean one with wheels.
I've actually been up in the air ambulance. I thoroughly enjoyed myself in that. Obviously, I had no part to play in flying the thing, but it was just amazing what they can actually do.
When we first found out we were going to get the air ambulance, we all had to go up to give us an idea of what it was about. And I was just amazed by the experience, really, how far you could see. In fact, I was so taken with it that when I went back to work, I actually handed in my notice to my boss and said that I was going to be a pilot, and that was it.
Well, Tracy hasn't actually given up her day job, but she and Marie do want to find out what it's like to be pilots.
I'm looking forward to it. The actual sitting in the driver's seat, so to speak, and taking over control, and actually how it works.
Well, I am a little bit concerned because Marie is a very fast driver, and I'm concerned that perhaps that's going to transfer to her being a very fast helicopter pilot.
And stop the nose rising. Look, see it's rising? Ah, nose, yeah? So you can see it was going to. What should you have done to stop it rising? Push it forward. Yeah. Do it. Don't be so shy. Okay? Yours on the stick.
Anyone who wants to be a pilot has to study the science of flight, and the first question is always, how does a plane or helicopter stay in the air?
I don't know how they stay up there. I know that they do, and I'm quite relieved that they do, but I don't know a lot about it.
To get into the air, you have to overcome the pull of gravity. To do that, the rotors send a huge amount of air rushing downwards. Believe me, I can feel it. And this creates an equal and opposite force pushing up on the rotors. And so the helicopter goes up. And for pretty obvious reasons, this effect is called lift.
As far as we're concerned, lift is what we produce to get 2.5 tons of helicopter up off the ground and accelerate it into forward flight. The blades are responsible for producing in a helicopter both the lift and the thrust to give it speed.
Basic thing about a helicopter is that it's much more simple than you probably thought. Okay, we just fly by using a wing, and we push our wings around in a circle in a rotary motion, so they're called rotors. And the big secret with a wing is that you've got to keep it moving through the air. If you've ever stuck your hand out of the car window,
Yeah.
you'll know exactly what a wing is doing. If you put it out of the window and it's really flat, then it slides through the air quite easily. And if you increase the angle of your hand, it's harder to push it through the air, but also you feel some lift
Yeah.
as well.
That's right.
Rotors are like the wings on an aeroplane. And if you look at the end of a rotor, it's got this streamlined shape called an aerofoil. It's the curvature on this aerofoil that gives a smooth flow of air over the rotor. Whether it's a rotor or a wing, it's the aerofoil that generates the lift. The shape and angle of the aerofoil in flight makes the air flow faster over the top surface than underneath. The faster the air flows, the lower the pressure, and the difference in pressure between the top surface and the bottom means that the aerofoil lifts up.
Because of the conservation of energy, that faster flow has to get the energy from somewhere, and it gets it from pressure. So the pressure goes down to enable the faster flow over the top, and the differential in pressure gives you the lift.
All right, and as you can see there, that is a good video that really does explain everything for you. So basically, as I stated before, we're going through a journey through my daily life. And as I start, my cell phone does light up and plays music, sets an alarm. And this is thankfully because of James Clerk Maxwell. He contributed to science and comprehended light and how it moves. James Clerk Maxwell was able to make a mathematical equation from the concepts known about electric fields and magnetic fields and their interactions. This mathematical equation is called electromagnesium. His equation showed the electromagnetic waves travel through a vacuum. The waves travel equal to the speed of light. This is how the cell phone can be charged. So thankfully, not just, do I use my cell phone on my journey through going to work. I use it for multiple purposes: to communicate, to surf the internet, to make telephone calls, to take photos, to look up important information on a database that I can use for work when I'm up in the air flying around. So not only does James Clerk make some good contributions to physics, there's also quantum mechanics that the cell phone can be used for multiple purposes. Max Born was the first physicist that coined the term quantum mechanics. So quantum mechanics is a physical science that deals with the behavior of matter and energy on the scale of atoms and subatomic particles or waves. So, in the beginning, there was an old theory that was, it wasn't not old theory, but the old quantum theory that was made by Albert Einstein and Niels Bohr. And then it just ended up progressing to what Max Born had, where through a computer and a cell phone, you were able to send messages down the fiber optic cable. When you want to use the internet on your phone or on your computer, when you're flying and want to use high-speed internet, you are using quantum physics. The light source used to send messages down the cable provides us internet. So we can get any information at any point in time about any topic, really. And as my journey is continuing through the day, I not only use my cell phone and computer, but I use other theories of my job, and as stated in that video before, the theories of flight, aerospace. So we talk about Newton's third law of motion, 3 laws of motions, the hydrodynamica, and the concept of inertia. And as stated in that video, it pretty much explains everything. The Newton's laws of motions, which are: the first law, an object at rest remains at rest while an object in motion remains in motion unless acted upon by an external force. And the third law, every action, there's an equal and opposite reaction. So through Newton's 3 laws of motion, you can understand how a helicopter or a plane takes off. And then there was also Daniel Borelli, who basically did the publishing of the hydrodynamica, which is the study of how fluids behave when they are in motion, and how he said that air is considered fluid because of how it flows and takes a different shape. And just like the video was talking about, air is flowing past the top surface of the aircraft's wings and moving faster than the air flowing below the bottom surface, hence the pressure difference which caused the lift of the helicopter. And then we'll talk about the concept of inertia, which is Galileo Galilei took both the methods of Newton and expanded them, and then made his concept of inertia, which is that an object remains at or in motion unless acted upon by another force. And all these theories together tie together to understand that it takes lift, thrust, and torque. Just like this picture here reiterates. And then I'll also talk about Einstein's theory of relativity. This just is just a continuation of understanding the concept of flight and another scientific method. And let's just state that I'm going in my helicopter, moving fast, and I see another helicopter approaching us, or we're approaching that helicopter, and we're moving past them. It feels like that helicopter is moving slower, and it's getting smaller and shorter, and slowly time is changing, and the time is moving different for that other person in the helicopter than it is for them. This is considered Einstein's theory of time dilation. This is a little bit of a photo here just showing how that exactly works. And Einstein showed that space and time are intertwined based off of these two concepts, and those are his theory of relativity. And then lastly, I will talk about the last scientific method as I'm going through flight and we're at cruising altitude and we turn on the heat or the air conditioning. And here I think about the fact that there could be a scientific method related to the heating of the helicopter and what the patient and crew thinks of the temperature. How do they figure out what temperature works best in which situation? Are there a way for the heater and the air conditioner to work in real time? If people are more comfortable, will it improve their overall health and productivity? Taking into account how people experience temperature and the altitude that they are flying. Overall, these are all a theory or concepts that we could be thinking about, or scientific methods that we could be thinking about while we're flying in that helicopter. And during that flight, those are other ways that we can experience the flight itself. So this is my journey going through work. I hope you enjoyed it and understood it very thoroughly.